So now we're going to talk about audio alarm devices. Audio alarm devices. This can either be electronic sounders or bells. Generally, the audio alarm devices are provided in a system for life safety protection. So they are provided for life safety protection. However, in a building that is a property only protection, that has only property only protection, sounders, audio alarm devices are also required. They are required so that the firefighter can locate the location of the sounder and also the location of the entrance into the building. So what you normally want to do is to provide a sounder adjacent to the fire alarm control panel, and also provide a sounder outside the entrance door. In order for us to design the location of the audio alarm devices, what we need to know some information about the building. So number one, we need to agree what is the evacuation strategy for the building. After this evacuation strategy can either be a full evacuation or phased evacuation. If it's full evacuation, then we don't need a zone chart. But if it's phased evacuation, we need the alarm zone chart. And this alarm zone chart needs to be marked on the drawing. Also, we need to know the sound level that is required in each room, and we shall talk about this briefly. And also, we need to know the fire compartment layout for the building. So after we've got all this information, and then we can now go into citing the alarm fire sounder devices. The the sounder device is the sounder devices they are cited based on the sound level that is required in a room. So typically, according to the standard, to the regulations, the sound level required in a room should be at least 65 dBA and a maximum of 120 dBA. Anything above 120 will cause damage to the hearing. So what we want to achieve is 65 at a minimum of 65 dBA in a room, and maximum is 120 dBA. Usually, there are some exceptions to this rule, and these exceptions are as follows. In the stairwell, we would need a minimum of essential to have a sounder on. If you have like a multi-story building, you don't really need a sounder on each landing. You can space it within the landing so that you can achieve a minimum of 60 dBA. The mistake designers usually make is to provide sounders on each level in the staircase on each landing, and as this area is where people are evacuated in the fire alarm, whether in a fire alarm incident, it's usually very very loud and can cause damage to the hearing. So an exception is to have 60 dBA in the stairwells. Also, you can have 60 dBA in an enclosed room that is less than 60 square meters. It's typically like small offices and meeting rooms. You don't want the sound levels to be too high in these rooms, so can go as low as 60 dBA. Also, there are some in areas that are not areas that are less than 1 square meters and are not habitable. So just as like maybe like toilet lobby, like little lobbies. You don't really need a sounder in these spaces. Where the background noise is greater than 60 dBA, like where there's machines and workshops, the sounder needs to be 5 dBA above the background noise. 5 dBA above the background noise, but not more than 120 dBA. So if you have your machine and the sound of the machine is greater than 60 dBA, let's say for instance the sound of the machine is 70 dBA, then your sounder needs to be at 75 dBA, 5 dBA above the background noise. In rooms where you need the alarm to wake the occupant up, the sound level needs to be 75 dBA. So 75 dBA in rooms where the alarm needs to wake people up. Where there are some instances where you can't install a sounder within a room, the sounder can be placed outside the room, but then you must be cautious. You must be aware that the door will reduce, there will be a loss of sound through the door and through the walls too. So typically you have 20 dBA for normal doors and 30 dBA for fire doors. So if you place your sounder outside a room, you will typically have 20 dBA loss through a normal door and 30 dBA loss through a fire door. Now, when you are designing, so once you've what you do is, once you have your drawings, and then in each of these spaces you now need to mark, okay, this is the sound level I need in these spaces. You write the sound levels down on the drawing, and then you now start locating your sounders in the room. It's not easy to actually know the sound levels that will be achieved, because when the building is occupied and you have furniture, you have your carpet and you have people in, this affects the sound levels. So what we normally do is, indicatively we locate the sounders, and then we make a note that the installer should test the sound levels before leaving site, record it, and ensure that the levels achieved complies with what the design requirement. It is, and one thing to note is, it is preferable to use multiple quieter sounders to achieve your required level, rather than a few number of loud sounders. So it's better to have more smaller sounders than large ones. Also, what we also need to note when we are, apart from providing the sounders based on the sound requirement, is that each fire compartment should have a sound, at least a sounder in each fire compartment. So when we said in the beginning that what is required is, you need to have your fire compartment drawing with you from the fire engineer, so that at least when you're doing your design, you can provide a sounder in each fire compartment. Lastly, when you are designing, you shouldn't mix sounders and bells together. There should be a common sound throughout the building, so you're not allowed to mix sounders and bells. And if you are working in a building, maybe it's an existing building, and there's an existing fire alarm system, and you need to upgrade or redesign the fire alarm system in an existing building. If you cannot find a sounder that will match the existing fire alarm bells or sounders, then you have to change the entire sounder in the building. So that's one thing you've got to note. If you are upgrading a fire alarm system and you need additional sounders in the building and you can't find a sounder that will match what is existing, then the entire sounder system in the building needs to be changed. So it's something you need to be conversant with. So lastly, when you're designing, designing a sounder is not a straightforward science. So what we as designers do is we provide an indicative layout of the sounders, and then on the drawings too, we indicate the sound levels we want to achieve, and then we make a note that the installer, after installing the sounder, they should test it and make sure that it achieves that level, and if it doesn't achieve the level, they should make sure that additional sounders are provided. Also, they should make sure that the sound levels in the room is not above 120 dBA. Because anything above 120 dBA on a hearing on a continuous basis can damage the hearing. So this is all about the sounder system.